Hello, pre-calculus people. This is our first video lesson 0 for multiply and divide rationals. Those are fractions and working with complex fractions. All right, simplify. First one, we just have one fraction. Just a little reminder here. Simplify also means we have to reduce. So to reduce, we're looking for common factors. Remember, we cannot reduce terms. Those are parts of addition and subtraction. We can only reduce factors. We have to split it into multiplication. Something like, let's see, 5 over 10, we can only reduce because the numerator can factor into, well, it's just 5, or we could write to 5 times 1. 10 is 5 times 2, and the common factor, when it's multiplied, common factor reduces, and we get 1/2. So that's what we're looking for. We have to factor and then reduce out, cancel out common factors. So on number 1, we cannot cross out the x squared because we have parts of addition and subtraction in there. Factor first. All right, the numerator. Go through our factoring. We've got a GCF in this, so that's 5. Now, if we want to just do this a little bit quicker, we can take the 5 out, and that's x squared minus, that's going to be a 4. That's going to be a 4. So I'm going to factor x squared minus 4x plus 4. That's going to be x minus 2. And if you notice, this one's a perfect square. We could say x minus 2 times x minus 2, or just squared. In the denominator, one thing I notice is the x squared, the lead term, is negative. So I'm actually factor that negative 1 out. And if we do that, we get a negative 1. We've actually got negative 4 plus x squared, or x squared minus 4, which is x minus 2, x plus 2, difference of squares. So one of the x minus 2's will cancel. We can just cancel 1 there and 1 there. And we are left with the reduced form. Let's see, we have an x minus 2 on top. We've got the 5 on top. On the bottom, we have the x plus 2. We've got this negative. We'd like everything to be as combined as possible. So that negative 1, we just have 5 divided by negative 1, which makes it negative 5. That's the best way to reduce. We have our binomials, we have lead terms positive. We'd like to have x instead of 2 minus x. We'd rather have x minus 2. So we'll keep the negative, all one coefficient, out in front. All right, number 2, now multiply. So multiply and divide, we're going to be doing add and subtract later. Remember, multiplying is the easiest. You just multiply straight across. We're going to make this as easy as possible. So first thing, we are always going to reduce. So in a fraction, we can reduce, and remember, n to the 5th just means 5 n's. And squared means 2 n's, and 2 of them will cancel out. Hey, that's just subtraction. So we're left with n to the 3rd on top. Same thing over here. 3 of them will cancel, and we're just left with an n on the bottom. The second fraction, we can also reduce 10 and 14. Reduce by 2, you end up with 5 and 7. Now remember, when you multiply, it's not cross multiply. You're going to multiply straight through the numerators and denominators, but you can cross cancel. Any numerator factor can cancel a denominator factor when they're multiplied. So 7's cancel. We're getting a lot of stuff here. 5's cancel. It's getting pretty messy, but all I have left with is n cubed on top and an n on the bottom. So if we have that left, well, one of them can cancel, and we have n squared for the full answer. So we can write out farther, but hopefully you can follow along with everything we were crossing out as we went along. There's a lot of different ways to cross-cancel different things in there. But remember, with multiplication, any factors cancel from a numerator and denominator. So let's simplify this with multiplication. So remember, we need to factor first. We cannot just cancel out the same terms. They have to be same factors. Factor everything first. Really, this page is a full exercise in factoring. You're going to factor a whole bunch of stuff and get a lot more practice. Things will be in common. You'll cross those out. So we're multiplying. Numerator. The numerator of this one is, we've got minus 9 plus 20. So that's going to be minus 4 minus 5. On the bottom, we have minus 8 minus 5. Already see something to cancel. Second one, we've got 13 and 42. That's going to be minus 6, minus 7. And the bottom, we got 11 and 28, minus 4, minus 7. Remember, multiplication here, any numerator can cancel any denominator factor. So as we go through, it's not just the x minus 5s, those cancel, the x minus 7s, but we also have this x minus 4, one from the first, one from the second, because they are multiplied. So that's all the reducing we can do, and now we end up with the x minus 6 on top and the x minus 8 on the bottom. There's our final reduced simplified solution for that one. All right, this one, simplify. We've got division. Look very carefully at the problems in here. It's hard to miss that little symbol in between. So might have had some little shortcuts to say division, but division, we can change any division to multiplication. All right, so division is multiply by the denominator, or the reciprocal. What am I saying? Reciprocal. You're going to flip out over the second one. Copy dot flop, if you remember that, or copy dot flip, whatever your about sixth grade teacher took you through there. But to divide, we multiply by the reciprocal of the second fraction. So we do have to factor. We're going to change it to multiply. We can factor all at the same time. So like the first fraction, well, there's our cubes again. Remember, cube roots on this one. We've got x minus 2, and remember it is the first one squared. Opposite sign, first and second, 2x, always positive, and square the 2 is 4. X squared plus 2x plus 4. On the bottom, difference of squares, x minus 2x plus 2. Multiply, and we've got to flip this one over. So the x cubed plus 8, that's going to go in the numerator, and that's going to be x plus 2. Almost the same as the other numerator, but the signs are different. So x squared minus 2x plus 4. And we have the numerator becomes the denominator. So that one is, well, x squared plus 2x plus 4 does not factor. So it is just x squared plus 2x plus 4. Now, we're lucky that we factored all these because we have to look for common factors like the x minus 2. Got that. We've got an x plus 2 on top and bottom once we've changed to multiplication. And the entire factor, we said we can't do individual terms, but the whole factor of x squared plus 2x plus 4 cancels. All we're left with on this one is a piece of the numerator, the x squared minus 2x plus 4. That didn't factor on its own before, so it's not going to now. That's the simplest form we get. All right, complex fractions. To simplify a complex fraction, complex fractions are just fractions inside fractions. So we have one big fraction here with our numerator and denominator. Then in each one we have these little fractions over x squared in each one. So to simplify these, there are a few ways we could go through it, but we want to concentrate on trying to do things the easiest way, the most efficient way possible. And when you've solved other problems with fractions, just going back to algebra 1 even, you just want to get rid of all the fractions. And to get rid of a fraction, you need to cancel the denominator, and that's by multiplying. So to simplify, we're going to multiply the top and bottom of this whole big fraction by a common denominator. So that's the idea. So we're going to multiply, and this one is top and bottom. There's not two sides of an equation, just top and bottom of the fraction by a common denominator. Now, we would like the least common denominator, but if you don't use the least one, you can still do it. You just have more reducing at the end. But this idea is going to come back to us again and again. If we want to multiply by a common denominator, we're going to build it. We're going to build it out of the pieces that we want to cancel. So as I look through this, here's what I'm going to do. In this, this numerator, you can start with any of these. We have to cancel out two different fractions. The first one has an x squared on the bottom. So we're going to multiply by x squared. Now, if there's more, there's another fraction, I need to cancel an x. What you have to think of is, will x squared cancel an x? And it will, because this is x times x. There's factors. So that's good. All we need is an x squared. Now we have to do that on top and bottom. But check the fractions on the bottom as well. X squared will cancel x squared, so we're good there. X squared will cancel an x, we're good there, and the 1 is already fine. So we just built it as x squared. We'll cancel out every denominator as we multiply through, and we are going to distribute this. Okay, it's really in group here and your group there multiplied by x squared. So we're going to try to build it out of the denominators that we see, make sure each one has enough to cancel. So what we get is x squared times 12 over x squared, and that one, the x squared, cancels, and we just have 12. You'll see a pattern here. 8 over x, we're going to have minus 8. 1x cancels, and we have an x left on top, minus 8x. We get rid of the fraction. And 1 times x squared is plus x squared. On the bottom, same thing. So distribute through. 30, the x squared on the bottom cancels, so just 30. 11, 1x cancels, so it's minus 11 and a single x, and plus x squared. So these are written backwards, but they're quadratics, so we should be able to factor and cancel. You always have to reduce fractions, and that means factor and cancel. So the top one, it's a little backwards, minus 8 and 12. Positive 12, that's going to be minus 6 and minus 2. On the bottom, minus 11 and positive 30, that's going to be minus 6 and minus 5. X minus 6's, we got them, they reduce. So x minus 2 over x minus 5 is what's left. So multiply through the full big numerator and denominator by a common denominator from the little ones. And we're going to see that a lot with fractions. We want to cancel out denominators that we see. All right, so the last one, another piece with a complex fraction. This one has 3 separate fractions in here, all in one big fraction. So we are going to build a common denominator to multiply by. All right, so go through each one. 1 over x needs an x to cancel it out. X will cancel x, and that fraction will be gone. The x plus 1. Now remember, to cancel has to be a common factor. The x will not cancel the x as part of the plus 1. I can't just put a plus 1 here, or that ruins the first fraction. So I need a separate piece here. So x and an x plus 1. That is what's going to cancel the x plus 1 in the second fraction on the numerator. 1 over x plus 1, we've taken care of that with the x plus 1, so we don't need another one. So build it out of the pieces you want to cancel. All right, first fraction, the x part cancels. We're left with 1, and we have to multiply by the x plus 1. Minus, second fraction, minus 1. X plus 1 cancels, and we're left with x. So we have 1 times x plus 1 minus 1x. On the bottom, the x plus 1 cancels. We're left with 1 times, and we just have an x left. So just 1x. Simplify that out. I'm going to just write this, multiply the 1, x plus 1 minus x over x. Those x's, x minus x is gone. So we're left with a nice little fraction, 1 over x is what that all simplifies to. All right, that is our complex fractions. So that'll get you through 0.4. So 0.4 on this one, we are doing all of that. And remember, these are due the next time you are in class to be submitted to Schoology. All right, a lot of factoring. In this one, show all your work carefully. Just be careful with all those positive, negative signs and all the factors. Watch out for the division that you have to flip over and common denominators for all complex fractions. All right, that does it for 0.4. We'll see you on the next one.